Okay, now that the cam's degreed in, now's a good time to do a double check. And that is, I'm going to double check piston to valve clearance again. Now this has already been checked once during the mock-up stage, but now that the cam is in the position where it's really going to be in the engine, we're going to double check it again. And you'll notice that I have some clay, and the reason I like to do it with clay is because the valve is going to make an indent in the clay, and then I can take a razor blade and I can slice the clay around and see not only the thickness, but I can see also the radial clearance between the edge of the valve and the outside of the pocket. And the reason I think that's important is because the piston has a tendency to rock across top dead center as the engine's running. And we don't know exactly how much it's going to rock, but I do have to know what the maximum and minimum is, and that is what clearance I have at the top of the piston between the backs of the rings and the piston. So the piston can't rock but so much. So knowing how much it can rock, I know if I have more radial clearance than that, then I can determine that it's not going to touch when the engine's running. Okay, I've got the head bolted on. I've got the lifter down on the base circle, and now I have also set my rocker arm in the geometry that I want it, which now is also a good time you can measure your push rod. Since you're a little bit away from final assembly, your push rods will probably be here by the time you get the engine assembled. So good time also now to measure your push rod. One other thing to look for is when you're rolling the engine over through the rotation is make sure that your push rod is going to clear the head. That's usually not a problem on rocker arms that are the stud and girdle type style, but in some engines where we're using like a Jessel rocker arm or something like that, where the lengths can be different because they've moved the trunnion, then that's a good time now to check. Now this push rod is a little bit bigger actually than 3/8 diameter. That's why I have the guide plate off of it, because it won't fit in a standard guide plate. So anyhow, now I'm going to roll over the engine, let the valve do its job down in the clay, and then we'll take a look at it. Okay, I've got the head back off the engine, and one thing I did forget to say when I had the head on the engine and I was setting up the rocker is I prefer to set this, my valve lash at 0 when I'm doing this. And the reason I do that is because piston to valve clearance, I'm actually going to gain my lash clearance. And the other thing I'm also going to gain is I'm going to gain a little bit more clearance due to the cam will be a couple degrees bigger in duration with the lash ramp included in it. So I will actually gain piston to valve clearance when the engine is in actual setup running condition with proper valve lash than it would be the way that it just set it up. So I'm looking for worst case scenario. So here we go. We'll take and make sure your caliper is zeroed when you set it up. So we got our caliper set at 0, and then what we're going to do is we're going to check our depth, and you'll see our depth is about 88 thousandths. And then we'll check the depth over here. And over here we have about 80. And we'll check all the way over here at the extreme edge. And over here we have 80 as well. Now the next thing to do is to go ahead and slice some of this just to check out our radial clearance. So we'll go right into here. And you'll see I also have, you see the clay is a little bit shiny. I usually put a little tiny bit of oil on top of the clay just so that the valve doesn't stick down in the clay and pull it back off as it's going back up. So with the back of there, you can see that the radial clearance from, I have that much from there all the way back to there. So I have a lot of radial clearance. I have probably 100 thousandths of an inch. And as I go ahead and dissect into this, you'll see again how much radial clearance is there. So making that radial clearance and recutting the pistons was a good option. So I'll continue to dissect this and go around, and basically what I do is I just keep cutting some small pie slices and make sure that my radial clearance stays consistent all the way around. Okay, we're all cleaned up. So now we'll go ahead and feel safe to put the other 7 pistons in it, that we have a double check on it. So it's been checked once during the mock-up. Now it's been confirmed as the engine will actually run that we have plenty of radial clearance, plenty of thick valve clearance up and down. And as you see there, you can see where the piston, before when I sort of laid back the radius a little bit just to make sure things are good. One thing that went on also during the mock-up, which I didn't show double checking piston and the valve clearance is I usually put a little bit of clay right around the edge of, if there's a little bit of dome on the piston like what this one is, I usually put a little bit of clay right around that, and then I'll turn the engine over and just see how it looks as far as clearance to the combustion chamber, the head, because what you also don't want is you don't want with whatever piston rock you have, it can raise slightly on one side or slightly on the other side as the piston rocks back and forth. So you just want to make sure you have good clearance between your combustion chamber and your head, so that you don't have that incidentally, just even the smallest amount. If it taps the head, what happens is it unseats the rings, and as it unseats the rings, you don't get all the benefit of having your cylinders honed properly and all the sealing you can get, which results in not as much power as you can get. So you know, when you're doing that, just make sure that everything is looking good. This piston again does have the rings and everything on it, so when I mocked it up, I went ahead and mocked it up this time, piston to valve, just as it's going to be in the engine with rings, everything just as it is. So we're all ready. We're good to go.